Welcome. In this video, I'm going to show you how to find the sequence of partial sums for an infinite series. Now, we're not going to rigorously prove whether this converges or diverges. We're just going to look at the partial sums, we're going to find decimal approximations, and we're going to try to get an intuitive feel for whether this infinite series converges or diverges. More importantly, by the end of this video, you will know what a sequence of partial sums is. First, let's begin with the first partial sum. This is a finite sum from 1 to 1 in this case. And we keep our expression for our infinite series, that should be a k. So this is negative 1 to the 1 minus 1 power over 1 factorial, which is just 1. The second partial sum is the finite sum from 1 to 2 of negative 1. And again, this expression remains the same. So I'm going to take my first partial sum here, which is 1. And to that, I'm going to add negative 1 to the 2 minus 1 power over 2 factorial. That's 1 minus 1 half. My third partial sum, S sub 3, is the finite sum from 1 to 3 of the expression here for our series. So again, I'm going to take the first partial sum, which is 1, the second partial sum here, which is the first one minus this second term. So 1 minus 1 half. To that, I'm going to add negative 1 to the 3 minus 1 power over 3 factorial. That's 1 minus 1 half plus 1/3. And that works out to be 2/3. And actually, this one here is 1 half. When you're looking for patterns, I'm going to suggest you stop right before rewriting this as all one fraction. For this one, it won't matter so much, but for future examples, it might. Now let's do one more. Actually, I asked for 5, so let's do 2 more. So as you can see, I went ahead and made some space so I can fit the last 2 partial sums, and I'll shrink them down to match the same size when we're done. The fourth partial sum, again, is a finite sum from 1 to 4. The expression remains the same. And I know the third partial sum is 1 minus 1 half plus 1/3. And then to that, I'm going to add negative 1 to the 4 minus 1 power over 4 factorial. So this is, 1 minus 1 half plus 1/3 minus 1 over 24. And that equals 15 over 24. Let's look at the fifth partial sum. Okay, the fifth partial sum, S5, again, is another finite sum. Remember, partial sums are finite sums. And I'm going to take the fourth partial sum, and again, I'm going to take the long version before I simplified it, just to get in that habit. 1 minus 1 half plus 1/3 minus 1 over 24. Then to that, I'm going to add negative 1 to the 5 minus 1 power over 5 factorial. So this is 1 minus 1 half plus 1/3 minus 1 over 24 plus 1 over 120, which will be 76 over 120. So there are my first 5 partial sums. And as a sequence, we would write them as follows, as a sequence. 1, 1 half, 2/3, 15 over 24, 76 over 120, and so on. And I can also write this sequence as decimals. So this is the sequence of partial sums. And remember, to determine if a sequence converges, you just need to evaluate the limit of the sequence, see what it's tending towards. When you're looking at series, it doesn't quite work the same way. But for a sequence, we could look at the limit if we had a formula, some expression for the nth partial sum. But for now, we're just going to get an intuitive feel if we think this converges. So let's write this as decimals. This is 1, 0.5, 0.67, repeating. well, 0.66 repeating, excuse me, I should write that correctly. And we have 0.625, then 0.633 repeating, and so on. So what do you think? Looking at this, we're at 1, then a half, then about 2/3, which is 0.6 repeating, 0.625, 0.633. It looks like eventually this will converge, this sequence, to 0.6, because right now I see it going above 0.6 and getting closer and closer. Actually, not even 0.6, maybe 0.63, 0.62 something, because it goes above and below and above. So intuitively, I can say it does appear that this sequence of partial sums will converge. Okay, with that, I want to just quickly recap. A partial sum is a finite sum of the first n terms of an infinite series. So here n is 5, so we summed up the first 5 terms of this infinite series. The sequence of partial sums is just taking all of these finite sums and putting them in a list, in an array here. And then intuitively we can get a feel of whether or not this sequence will converge. And later on in this lesson, you'll get some tools that will help you determine whether or not the series converges based on this sequence of partial sums. All right, keep calm and math on.